This one is a carbon, hydrogen, 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 and this is a Z. Z is a more electronegative, right? Z is a more electronegative. Now in this manner you see Z, what it has taken, when it has taken this carbon bond pair of electron towards itself, electron. Now this carbanion will be in this manner. Now this carbanion will be in this manner. Now this is a carbanion. Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. Now in our organic chemistry series already we have completed the IUPAC lectures. Clear? Next we are going to start the general organic chemistry. Now in this general organic chemistry, whatever the concepts we are going to study, this concept entire our organic chemistry in application part, it will play very crucial role. Clear? Now here in this lecture we are going to study how to identify the electrophiles, how to identify the nucleophiles, and what are the reactive intermediates. Clear? And what are the permanent effects and what are the temporary effects. Clear? What is the inductive effect, what is the mesomeric effect, and what is the hyperconjugation. Now how this application of the inductive effect, hyperconjugation, and the mesomeric effect, how to apply to the carbocation, carbanion, and the which one, free radical, and how it is applicable for the identification of alcohol or acidic nature and basic nature. This in this lecture we are going to see. Now let's start our lecture. Now before going to start the general organic chemistry, now what is the GOC, general organic chemistry? Now in this organic chemistry, how the reactions will be happened, how the organic reactions, now the plenty of the mechanisms and the plenty of the reactions we are going to see, right? Now how these reactions are happening, now we'll see. First, in the organic reaction, the reaction to happen, first here we are going to take the reactant. Clear? Reactant plus reagent. With the help of, we have taken the one reactant. Now in the presence of which one, with the reactant, in the presence of solvent, what it will give? It will give you the product. In this manner organic reactions will be happen. Now what is the meaning of the reactant? Reactant, it is contain large quantity which present in the, if one reaction is happening, reactant will be present in the large quantity. Done. Now what is the meaning of the reagent? In the reaction, reagent will contain small quantity. Clear? Now what is the meaning of the solvent? Here the solvent, here we are going to take two types of the solvent. What? One is a polar and one is a non-polar. Clear? What is a polar and what is a non-polar? Already I explained you very clearly what is the meaning of polar and what is the meaning of non-polar. Now in the upcoming reactions, in the upcoming lectures also, we are more detailedly we are going to study which are the polar solvent, which are the non-polar solvent. In the upcoming in the upcoming lectures we are going to see. Clear? Now in this, to start the GOC, what the GOC, how the organic reactions will be happened in our organic chemistry. First, reactant which is present in the larger quantity. Next, reagent which is present in the smaller quantity. Now with the help of the solvent, either solvent may be the polar or the non-polar, it will give you the product. Clear? Done? Now here see how the organic reactions will be happen. Now the organic reactions to happen, now first bond breaking and the making is the first step. Breaking and formation of bond. Bond breaking and bond making is a first step. Clear? Now how the bond will break and how the bond will make, now we'll see. With the just one example I will explain. Here I was taken one CH3, one CH2, CH3, one hydrogen and one chlorine I was taken. Clear? Now this is the one reactant. Clear? Now this reactant with the help of which one? With the help of which one? What I said, with the reagent and with the in the presence of solvent, right? Now aqueous. Aqueous is nothing but H2O. H2O is our solvent. H2O is our solvent. Now KOH. This KOH is our which one? Reactant. Sorry, this is our reagent. This is our reagent. And it will give you the product. And it will give you the product. Done. Here it will give you the product. Clear? Now here two types of the product we will get here. Just to make you to understand, I was explaining one product itself. Here this is a reactant which is present in the larger quantity with the presence of H2O solvent, and this is reagent and it is giving the product. Now you see here the bond has been broken, here the bond has been broken. Now here the bond has been formed, here the Cl has been gone and the OH has been formed. Means bond breaking and the bond making. Breaking and the making is known as a organic reactions, right? Organic reactions. Now how many types of the bond breakings we are having? Now we have to see. Clear? How the in the organic reactions, how the bonds are breaking. Now how the bonds will be break? How the bonds will be break? Now breaking upon the bonds. Now what type of the intermediates or what type of the species it is coming? Now we are going to see. Clear? Now here in the organic chemistry, reactions occur by breaking and making of bonds. Breaking and the making of bonds. Clear? Here making and making, here we are having two types of breakage. Means organic bonds can be break into two types. What are there? First one is a homolytic. And the second one is a heterolytic. One is a homolytic, another one is a which one? Heterolytic. Clear? Now what is the meaning of the homolytic breakage? Homolytic breakage. Now what is the meaning of the homolytic breakage? Means symmetrical breakage. See, now most of our organic compounds are the covalent in nature, right? Clear? Now homolytic breakage means symmetrical breakage of covalent bond. Symmetrical breakage of the covalent bond is nothing but homolytic breakage. Clear? Now it leads to give, means homolytically if you break the bond, it leads to give free radical. What is the meaning of the free radical? I will explain very clearly. What is a carbocation? What is a carbanion? What is a free radical? Just you wait. Okay, just you follow the lecture. What is the meaning of the term free radical? I will explain very clearly. Don't worry. Okay, now you see here how the free radical are homolytically it is forming the bond. Now you see here this is a carbon. Done. Now here the one bond it is there. Done. Here this some X bond or X atom it is there. Here the electronegativity of this carbon and this X is almost equal. When this electronegativity difference of this X and the carbon is almost equal, now we know one bond contains two electrons. When you break this bond symmetrically, what it will happen? This electron will be shifted toward this carbon and this electron will be shifted toward this X, right? Clear? Now this leads to give the what? Free radical. This leads to give the radical. Clear? And this X radical. Done. Now this point or this electron we call it as a radical. Means homolytical or symmetrical breakage leads to give which one? Free radical. Symmetrical breakage leads to give the free radical. Sir, well known example for us, sir. Now if you take the Cl2. Now what is the meaning of the Cl2? Here this is chlorine and this is chlorine. Electronegativity between this chlorine and the chlorine is same, because this chlorine electronegativity value is 3 and this chlorine electronegativity value also 3. Clear? If you break this symmetrically, what it will happen? Two chlorine radicals will be formed. Done. Now next, if suppose any peroxide, organic peroxide, if they have given, then if I symmetrically if I break, then it will, what it will happen? This it will become radical. Done. Clear? Now here you have to remember some what symbols. Clear? Now what are the symbols you have to remember? Because these symbols in our entire organic chemistry we are keep on going to use. Clear? Now here this indicates that 2 electrons transfer. This indicates that 2 electrons transferred. Done. Now this symbol indicates that resonance. This symbol indicates that this is a resonance, and this symbol indicates that forward reaction. Clear? Now this reaction indicates that this is a backward reaction. Done. Next, this symbol indicates that this is a equilibrium. Clear? These are the symbols you have to remember. Now most of in our organic chemistry, these 2 symbols we are going to use repeatedly. These 2 symbols will play very crucial role while we are studying the mesomeric effect. Done. Now next type of the breakage we are going to see, that is which one? Electrolytic breakage. Next type of the breakage that we are going to see, that is electrolytic breakage. Now what is the meaning of the electrolytic breakage? Means, now electrolytic breakage means unsymmetrical breakage. Clear? Now unsymmetrical breakage, now it leads to give cation and anion. It leads to give the which one? Cation and the anion. Clear? Now you see here, this is a carbon, and this is X, let's suppose. Okay. Now what you say here, electronegativity of X is greater than carbon. Then if the electronegativity of X is greater than carbon, what it will do? It will take this bond pair of electron towards itself. And it will form the which one? Carbocation, or one cation it will give. Clear? And plus X minus and X minus. Clear? Now Now 1 minute. Next, here if suppose carbon and here it is some Y atom will take. Okay. Now this electronegativity of carbon is greater than Y atom. If the electronegativity of which one? Carbon is greater than Y atom, then what it will happen? This carbon will take the bond pair of electron towards itself, right? Then it leads to give the which one? Carbanion. Sir, what is the meaning of carbocation? What is the meaning of the carbanion? I will explain very clearly. Now you listen. Now we have seen by the homolytical breakage leads to give the free radical, heterolytical breakage leads to give the cation or the anion. Now based on this, after the breaking the bonds, next we are going to see what? We are going to see the reagents. Now the next step we are going to see, that is reagents, types of reagents, types of organic reagents. This is very important, my dear friends. This, if you remember, whatever the organic reagents that I am going to explain, if you remember, half of your organic chemistry will become easy itself. Clear? By seeing the reaction, I am saying, if you remember whatever the reagents I was explaining, there is no need to remember. Just that application, why it has came, why it is behaving as an electrophile, why it is behaving as a nucleophile, I will explain very clearly. But while if you remember, while seeing the whatever the organic question they have given, by seeing itself you can predict the answer very fastly. Now listen carefully. Clear? Now how many types of the organic reagents we are having? Now these organic reagents are classified into, these are classified into three types. Now what are the organic reagents we are having? Those are three types, right? First one is a free radical. Now second one we are having the electrophiles. Clear? Now third one we are having nucleophiles. Clear? Nucleophiles. Done. Now we see the what are the free radical. What are the free radicals? Free radical. Now what is the meaning of the free radicals? Now homolytical breakage leads to give the free radical, or heterolytical breakage leads to give the free radical? Homolytical breakage leads to give the free radical, right? Now this free radical contain single electron. This free radical contains single electron or odd electron compounds are called free radicals. Clear? Single electron or odd electron compounds, we call it as a free radicals, right? Now here second point, all the free radicals are paramagnetic in nature. Because due to the presence of their odd electron, it is paramagnetic in nature. When I start the reactive intermediates, there I will explain very clearly. Done. Now what are the examples for the free radicals or free radical reagents? Now we are going to see example for the free radical reagents. First one is a CH3 radical. Done. Next CH3 CH2 radical. Clear? Next CH2 double bond CH2 radical. Clear? Next, now X radical. Now this X radical may be the which one? F radical, Cl radical, Br radical and the I radical. Clear? Done. Next RO radical. Clear? Now here CH2 double bond CH radical, this is a vinyl radical we'll call. Clear? Now etc. These are the examples for the which one? Free radicals. Next one we are going to see second one. This is electrophiles. Next one we are having the which one? Electrophiles. What is the meaning of the electrophiles? How these electrophiles has been formed? Now this electrophiles has been formed due to the which breakage? Homolytical or heterolytical? Heterolytical breakage leads to give the which one? Electrophiles. Done. Now these electrophiles are the which one? Electron pair acceptor. Electron pair acceptors are called electrophiles. Clear? Are electron deficient compounds. Electron deficient compounds are called are called electrophiles. E and this positive charge indicates that electrophile. Okay, don't get confused. Done. Now here electrophiles, we are having two types. One is a which one? Positive electrophiles, and the second one is a neutral electrophiles. One is a positive electrophiles and next one is a neutral electrophiles. Now what are the positive electrophiles? Now we'll see. First one, positive electrophiles. Positive electrophiles. Now positive electrophiles are cations. Cations with what? Cations with electron deficient. Cation with electron, which one? Electron deficient or octet incomplete. Octet incomplete are example for the positive electrophiles. Are the examples for the positive cations with electron deficient are which one? Octet incomplete. Cations are examples for the positive which one? Positive electrophiles. Now here what is the general example for you? The well known example for you, if I was taking this CH3 plus, CH3 plus. Now you see CH3 plus means this carbon, hydrogen, hydrogen and it's hydrogen and it is a positive charge. Then this carbon to complete its octet, it requires 8 electrons. It requires 8 electrons, but it is having one bond contain 2 electrons, right? It is having only 3 bonds. 3 bonds, total 6 electrons, and this is a positive charge. Remaining to complete its octet, it requires 2 electrons. So this is electron deficient. So it is act as a electrophile. It is having a positive charge. Okay, but when it comes to the Na plus, this is very important. Na plus is, even though it is having the positive charge, it is not the which one? Electrophile. Why? Because you see normally sodium electrons are level. By the plus charge indicates that one loss of the one electron, right? By the loss of one electron. Now how many electrons are there on the sodium? 10 electrons. Then it is having the how many electrons? 10 electrons, right? Now due to the presence of these 10 electrons, it has reached to the octet. It has reached to the octet. This is very important. This is very important. Cation with electron deficient are octet incomplete only. This is octet complete species. This is not electrophile. This is not electrophile. Now what are the examples for the positive electrophiles? First is a CH3 plus. Done. Now next one is a CH3, CH3. Clear? Now this is a secondary carbocation, and the next one is a 3-degree carbocation. 3-degree carbocation. Done. Next vinyl carbocation. Next allyl carbocation. This is a allyl carbocation. This is a vinyl carbocation. Done. Next it is a benzyl carbocation. This is a benzyl carbocation. Clear? Next H plus proton. Done. Next one we are having the which one? X plus. X plus indicates that now Cl plus, Br plus, I plus. Clear? Done. Now hydronium ion H3O plus, H3O plus. Next Fe plus 3, Fe plus 3. Clear? Next benzene diazonium chloride, N2 plus Cl minus. Clear? Now these are the example for the which one? These are the example for the positive electrophiles. Positive electrophiles. Now we see the which one? Neutral electrophiles. What are the neutral electrophiles we are having? What is the meaning of the in that second one electrophiles? We are having the which one? Neutral electrophiles. Neutral electrophiles. What are the neutral electrophiles? Here all Lewis acids. All the Lewis acids are example of neutral electrophiles. All the Lewis acids are the example of neutral electrophiles. Clear? Now, what are the Lewis acids? Electron deficient. Electron deficient or octet incomplete species are the which one? Octet incomplete or octet excess. Octet incomplete or octet excess species are known as a which one? Which one? Lewis acid. Now listen carefully. First one, BF3 I was taking. BF3. Now in this BF3, boron, here this is a fluorine and this is a fluorine and this is a fluorine. Normally boron valency electrons are how many? 2s2, 2p1. 2s2 and 2p1. Clear? Now due to excited state electronic configuration, if it is gone to the excited state electronic configuration, now 2s1, 2p, this is 2s1, this is 2p2. Now for this boron, one p orbital is empty, right? One p orbital is empty. This is neutral. There is no any charge on the BF3. But even though there is no charge on the BF3, it is acting as a Lewis acid. It is acting as a Lewis acid. Lewis acids are nothing but electron deficient. Why it is electron deficient? Due to the presence of this vacant orbital. Now boron, due to the presence of this vacant orbital, whatever the electrons it is going to accept, that electron will be accepted to this empty p orbital. That's the reason this BF3 is a neutral electrophile. Neutral electrophile. Clear? Next example, BCl3, BBr3, BCl3, BBr3, next AlCl3, next AlCl3, next AlBr3, next FeCl3, next ZnCl2, next SnCl2, next CO2, next SO3. Done? Clear? Next singlet carbene. Clear? Next dichlorocarbon. Clear? Next dichlorocarbene. Next ozone. Next ozone. Next we are having the X2. What? Cl2, Br2, I2 and diborane, B2H6 and the BeCl2 etc. BeCl2 etc. Now these are the examples for the which one? Lewis acids. Lewis acids. Sir, you may get a doubt. Sir, how the CO2 has become the which one? Neutral electrophile. Then how the SO3 has become the neutral electrophile. Then now here this carbon has been attached with the two more electronegative elements, right? When this carbon has been attached with the more electronegative elements, now these more electronegative elements will take this bond pair of electron towards itself. When these more electronegative elements of the oxygen, when it is taking this bond pair of electrons of the which one? Carbon will get the partial positive charge. Clear? Now when this carbon is getting the partial positive charge, means this carbon is becoming the electron deficient, right? This carbon is becoming the electron deficient. Due to that electron deficient, now it will accept the electron. That's the reason this is a neutral which one? Electrophile. Then here sulfur also it has been attached with the three more electronegative elements. When this attached with the three more electronegative elements, now it is having the partial positive charge. It is having the partial positive charge. Then clear? Now these are the which one? Examples of the which one? Neutral electrophiles. Now we'll go with the nucleophiles. Now second one we are having the which one? Nucleophiles. Next one we are having the nucleophiles. How this nucleophiles has been formed? Nucleophiles has been formed on the basis of which one? Heterolytical breakage only. Heterolytical breakage leads to give the which one? Nucleophiles. In these nucleophiles, what are the nucleophiles we call? Electron pair donor. Electron pair donor. Electron pair donor or electron donating species. Electron donors or electron pair donating species are known as a which one? Nucleophiles. Now here the nucleophiles are also, here also the nucleophiles are two types. One is negative nucleophile and one is a neutral nucleophile. One is a neutral nucleophiles. Then now see, first one negative nucleophiles. What are the negative nucleophiles? Now we are going to see. Clear? Now CH3 minus. Now CH3, CH2 minus. Clear? Now here R, C, R minus. Clear? Now CH2 double bond CH2 minus. Clear? Now vinyl allyl carbanion. This is allyl, this is vinyl. Done. Now benzyl carbanion. This is a benzyl carbanion. Clear? Now next is a X minus. X minus is nothing but F minus, Cl minus, Br minus and the I minus. Clear? Next I3 minus, I3 minus and Br3 minus and etc. These are the examples for the which one? Neutral nucleophiles. Done. These are the example for the negative nucleophiles. Sorry, these are the example for negative nucleophiles. Now next we are going to see second one. We are going to see the neutral nucleophiles. Neutral, which one? Neutral nucleophiles we are going to see. Now what are the neutral nucleophiles? Neutral nucleophiles is nothing but, now neutral nucleophiles is all the Lewis bases. All the Lewis bases are neutral nucleophiles. All the Lewis bases are which one? Neutral nucleophiles. Are lone pair containing species. Are lone pair containing species. Are the lone pair containing species are the neutral nucleophiles. Example for the neutral nucleophiles. First one is ammonia. Ammonia, nitrogen contain the lone pair of electron, so it will donate very fastly. Done. Next one, primary amine. Done. Now second one, secondary amine. Done. Next 3-degree amine. Done. Next H2O, oxygen, it contain the lone pair of electron. Next alcohol, it contain the H. Done. Now next one, now RLi. Clear? RLi means this is a metal and this is a R. Now metal always readily take the electron, right? So when the metal is readily given the, metal is always ready to give the electron, right? Now metal is having the tendency to lose the electron. Clear? Metal is readily lost the electron means that electron will be taken by the R. So R will get the negative charge. Clear? This one will be the donated to the which one? Electron deficient species. Clear? Now in this RLi, clear? This one will also act as a which one? Neutral, which one? Neutral nucleophile. Clear? Now next lithium aluminum hydride. Lithium aluminum hydride also will act as a which one? Neutral nucleophile. Next alkene. Alkene, due to the presence of this weak pi bond, it will donate the electron to the electron deficient species. Done. Next triple bond. Done. Clear? And etc. These are the some examples of the which one? Neutral nucleophiles. Next ambident nucleophiles. What is the meaning of the ambident nucleophile? Means this nucleophile we are having the two attacking sites are nucleophile which is having two nucleophilic centers. Two nucleophilic centers are called ambident nucleophiles. Ambident nucleophile. Example, sir. Okay. Example. First one. Oh. Example for this one. Example for this one. First is a nitro. Clear? Now this oxygen, it is having the lone pair of electron, it can donate. Nitrogen is also having the lone pair of electron, it can donate. Clear? Next one, nitrito. Clear? Now this is a nitrito. Nitrito is also having the oxygen which is having the lone pair of electron. Nitro is different. This is nitrito. Clear? This is a nitro. Done? Clear? Next one, cyano. It can be donated from the carbon end, it can be donated from the nitrogen end. Clear? Next, NC. Clear? Next one, SCN. SCN. Next, NCS. NCS. Next, here CH2 double bond OH. Clear? Now this is a which one? Acetaldehyde. Normally this is a acetaldehyde. Now this one which is a which one? After the alpha hydrogen, this is alpha hydrogen, removal of this alpha hydrogen, this carbanion has been kept. Now this carbanion in the form of this delocalization, now you may not understand, but upcoming the classes you will get to know. Now due to this delocalization also, it can be act as a which one? It can be act as a which one? To ambident nucleophile. It can be donated from the carbon end, it can be donated from the oxygen end also. Then one it can donate from carbon end, one it can donate from the oxygen end. Clear? Now this is also one type of the ambident nucleophile. Now we are going to see the what? Reactive intermediates. So what is the meaning of the reactive intermediates? Reactive intermediates. Now what are the reactive intermediates and how it will play the very crucial role for this reactive intermediates only? Now whatever the effects, permanent effects that we are going to study, that it will be applicable for the which one? This reactive intermediates. How this reactive intermediates has been came? Now this reactive intermediates will come where? In the middle of the reactions. When the one organic reaction has been started, now this intermediate will be formed in the middle of the reaction. In the middle of the reaction. How it is forming in the middle of the reaction? Now you see. Just I was taking one reaction. These three are the different carbons. Now one alkali I was taking. Now in the presence of aqueous KOH I was taking. This is aqueous KOH. Clear? Now this is a solvent. Already I explained in the starting. Solvent. Now this is a reagent. Now this is our substrate. So this solvent, what it will do? It will break this bond homolytically or heterolytically. It will break the bond heterolytically, not homolytically. This solvent, what it will do? It will break this carbon and the halogen bond homolytically or heterolytically. Heterolytically it will break. When it has heterolytically it has been broken, what it will happen? Halogen is a more electronegative. It will take the bond pair of electron towards itself and it will move. When it has taken the bond pair of electron towards itself and it has moved, carbon got the positive charge, right? Carbon got the positive charge. When the carbon has got the positive charge, when this carbon has got the positive charge, now this is an intermediate. In the reaction, what? In the middle of the reaction it has been formed, right? In the middle of the reaction it has been formed. So we call this as a which one? So we call this as a reactive intermediate. Then after that we are having the which one? One reagent that is a OH. This OH it will go and attack from the above end, or it may be attacked from the below end. It may be attacked from the above end or it may be attacked from the below end, leads to give the product. One product, whatever may be the product, let it be. But this is a reactive intermediate. In this reaction, one intermediate has been formed. Which intermediate has been formed here? Carbocation as a intermediate formed. Based on this only, we are having the different intermediates will be there in our organic reaction. So how many types of the reactive intermediates we are having? First one is a carbocation. Second one is a carbanion. Clear? Now third one is a free radical. Now this free radical also will form in the middle of the reaction only. Clear? Next, fourth one we are having the singlet carbene. Next, fifth we are having the triplet carbene. Clear? Now these are the intermediates mainly we are going to focus in our GOC. Clear? How this carbocation, carbanion, free radical, singlet carbene and the triplet carbene has been formed. Now we are going to see. Then first, this carbocation, how the carbocation has been formed. First, how the carbocation has been formed. Now this carbocation will be formed on the basis of homolytic or electrolytical. Already I said electrolytical breakage leads to give the carbocation. Means here this carbon, here one hydrogen, here one hydrogen, here one hydrogen. Now here one Z atom I will take. Now Z atom is more electronegative than the carbon. Z atom is more electronegative than the which one? Carbon. It will take the bond pair of electron towards itself and it will form the carbocation. It will form the carbocation. Done. And it is a Z minus. Now we have to study about this carbocation. Now we have to study about this carbocation. Now how this carbocation, what is the hybridization of this carbocation, how this carbocation has been formed, now we'll see. Now before we have seen carbon, it has formed the bond with hydrogen and one Z, right? One Z. Normally ground state electronic configuration of the carbon is 2s2 2p2. Done. Excited state electronic configuration will be 2s2 2p3. Then when it has participated in the hybridization, it will be intermixed, right? When it has participated in the hybridization, it will be intermixed in this manner. Done. Now when it has intermixed in this manner, here each hybridized orbital we are having the 1 electron. Now you see, one hybridized orbital, it will form the bond with the hydrogen. It has formed the bond with the hydrogen. Now it has formed the bond with the hydrogen. It has formed the bond with the hydrogen. Now it has formed the bond with the which one? Z. Then Z. Clear? Now Z is this Z is a more electronegative, right? It will take this bond pair of electron towards itself. Which bond pair of electron it has taken? Carbon, right? Now carbon bond pair of electron Z has been taken. Done. Now for this one, for the before the 4 hybridized orbitals we are having. Now we got only the 3 hybridized orbital. One orbital is empty. One orbital is empty. Means it has this, we call it as a pure p orbital. This we call it as a pure p orbital. This empty pure p orbital, is perpendicular to the which one? 3 hybridized orbitals. 3 hybridized orbitals. Means this is a carbon. Now this is a hydrogen. Now this is a hydrogen and this is a hydrogen. Now whatever this orbital we are having, this positive charge will be present in this p orbital. This p orbital, whatever the charge is present, that orbital lobe will be perpendicular to this one. Now how it will be appeared? Now I will show you. Now you see here. Now you can see. Now this is a carbon. This one is a carbon. Hydrogen and this is a Z. Z is a more electronegative, right? Z is a more electronegative. Now in this manner you see. Z, what it has taken? When it has taken this carbon bond pair of electron towards itself. Now this carbon, whatever the orbital it is there, that it should be empty, right? That it should be empty. Now consider this is a empty orbital. Now this is a carbon empty orbital. Now you see this is a carbon empty orbital. This carbon empty orbital is perpendicular to this hybridized orbital, right? Means perpendicular with this carbon and nitrogen, perpendicular with this carbon and nitrogen, and perpendicular with this carbon and nitrogen only, right? Clear? Is it clear? Done. Means here for this carbocation, whatever the empty p orbital, whatever the positive charged orbital it is present, that is perpendicular to these hydrogens. This is a very key point you have to remember. Done. Clear? Perpendicular to the hybridized orbitals. Now based on this perpendicular to the hybridized orbitals, now it is perpendicular to the hybridized orbital, right? Now what is the hybridization of this carbocation we have to find. Now here this whatever the carbocation it has been formed, whatever this carbocation it has been formed, this carbocation hybridization, this carbocation hybridization is sp2 because 1 sigma, 2 sigma, 3 sigma. Hybridization number 3 we got, that is sp2. Already I explained very clearly. If you have missed that lecture, go and see in the organic playlist channel or in my channel, the playlist, organic playlist I was kept, you go and see over there. Done. And number of electrons around carbon, number of electrons around carbon is 6, right? 1 2 3 4 5 and 6. Clear? Now this is electron deficient, right? Electron deficient. Why it is a electron deficient? Because its octet has been not completed. Octet this is octet incomplete. Done. Clear? Now these are the some properties about the which one? Carbocation. These are the some properties about carbocation. Clear? Now here this carbocation. Now at the last we are going to study in the different manner carbocation, carbanion, free radical and the carbons, that all we are going to see in the last. Next one, formation of carbanion. Next we are going to see the formation of carbanion, how the carbanion is forming. Now in this carbanion, here this is a carbon, hydrogen, and here I was taken one Y. Clear? Now here the electronegativity of carbon is greater than Y. When the electronegativity of carbon is greater than the Y, now carbon will take that electron. And Y will get the positive charge. Now we have to study about this carbanion now. Clear? Now in this carbanion, already excited state electronic configuration of the carbon directly I was writing. Now this is one electron in the each excited state orbital. Now one is bonded with the hydrogen, one is bonded with the Y. Done. Now this carbon has taken this Y electron towards itself, right? Then in that orbital, then this is a one negative charge indicates that 2 electron. One negative charge indicates that 2 electrons. Now you see here. Now this is a carbon, hydrogen and hydrogen. Now this is a Y. This is a less electronegative, right? Less electronegative. When this carbon has taken this bond pair of electron towards itself, now this is a which one? Carbon lone pair of electron. Now this carbanion will be in this manner. Now this is a carbanion. Clear? This is a carbanion structure. Now this is a lone pair, right? Negative charge indicates that you can see carbon one electron is there. Now this Y atom electron also it has taken. So one negative charge contain how many electron? 2 electron. One negative charge contain 2 electron. This is the structure of the carbanion. This is the structure of the which one? Carbanion. No. Here. What is the hybridization of this carbanion? 1 sigma 1, 2 sigma 1, 3 sigma 1 and the lone pair of electron. Hybridization number 4 means that is sp3. Done. Now sp3. Now what is the geometry? For the sp3? That is pyramidal, right? That is pyramidal. Clear? Now bond angle 109 degrees 28 minutes. 28 minutes. Clear? Now this is electron deficient or electron sufficient. This octet has been completed, right? This is electron sufficient. Done? Clear? Now, next comes to the which one? Free radical. Third one is a free radical. Here the carbon, here the hydrogen, here the hydrogen. Now here one some X atom I will take. Electronegativity of carbon and the X atom is same. Then when I was homolytically broken, this carbon has taken this bond pair of electron and the X has been taken this bond pair of electron. Now you see this carbon, one electron it is present, right? One odd electron it has been present and the X it is come. Now you see Here, how many electrons that carbon it is having? How many electrons that carbon it is having? Total 7 electrons, right? 7 electrons it is having. Means one odd electron. This is a odd electron. That's the reason unpaired electron. One odd electron is present. That's the reason free radicals are paramagnetic in nature. I explained very clearly. Done. Now, first one. What is the hybridization of this one? This hybridization is the sp2. sp free radical hybridization is the sp2. Clear? Now, sp2 means we know bond angle will be the how much? 120 degree. 120 degree. 120 degree, and the geometry is which one? Geometry trigonal, planar, and electron deficient, and the electron deficient. Is it clear? Done? No. Next carbon. What we are going to see with the which one? Singlet carbon. Singlet carbon. Now, how the singlet carbon will be there? Now, this singlet carbon hybridization is sp2. Now, this singlet carbon hybridization sp2 means, now how many atomic orbitals will be intermixed? Only 3 atomic orbitals will be intermixed in the sp2. One hybridized one orbital will be the pure p orbital, right? Pure p orbital. One, this is a pure p orbital. Now, this pure p orbital will be perpendicular to the hybridized orbitals, right? Now, in this singlet carbon, now the singlet carbon will be in this manner. One hydrogen, and it has formed the one hydrogen. Now, here, this is one hybridized orbital. Now, this is which hybridized orbital? This is sp2 hybridized orbital. This is sp2 hybridized orbital. In this sp2 hybridized orbital, we are having the 2 electron, and one pure p orbital will be perpendicular to this hybridized orbital, right? This is a pure p orbital. Now, in this manner, how the singlet carbon will be there? In this singlet carbon, whatever the 2 electrons it is there, that it will be present in the which one? sp2 hybridized orbital. sp2 hybridized orbital. Now, what is the hybridization now? 1 sigma bond, 2 sigma bond, and 1 lone pair. Clear? 2 electrons, right? 1 lone pair. Or else, if you want to find why we are saying this as a singlet carbon means, now you can see these are the electrons, right? These are the electrons. Now, how to find the spin? 2s plus 1, 2s plus 1. Now, this spin, one is in the above, that is a plus of, one it is in the below, means that is a minus of, right? Plus of and the minus of, spin is 0, then s is become 0. If the s is become 0 means that it will be equal to 1. That's the reason this is a singlet carbon. This is a singlet carbon, and this singlet carbon hybridization is sp2. Singlet carbon hybridization is sp2. Now comes to the triplet carbon. Triplet carbon. Now we are going to see which one? Triplet carbon. What is the meaning of the triplet carbon? Now this triplet carbon hybridization is a sp. Triplet carbon hybridization is sp. Now in the carbon sp hybridization, now these are the hybridized orbitals. In the sp hybridization, how many atomic orbitals will be intermixed? Only 2. Only 2. And the remaining 2 pure p orbitals we are having, right? These 2 pure p orbitals, 2 pure p orbitals are perpendicular to the sp hybridized orbitals. sp hybridized orbitals. Clear? Now, here this is a carbon. Now, one sp hybridized orbital, it has formed the hydrogen. Now, one sp hybridized orbital, it has formed the one bond. Now, 2 pure p orbitals will be perpendicular to each other. Now, one will be in this manner and one will be in this manner. Now, each one pure p orbital, we are having 1 electron. One, let's suppose this is a px. Now, this is a py. On px we are having 1 electron, and the py we are having the electron. Now, why we are saying this as a triplet carbon means, if you calculate the spin 2s plus 1, now each orbital we are having the 1 electron, right? Now 1 electron with the which one? Of above spin, this one will give you the plus of, it will give you the 1, right? Now 2s we got it as 1 plus 1, it will give you the 3. That's the reason this is a triplet carbon. That's the reason this is triplet carbon. Now whatever the reactive intermediates we have studied, that in the only in this one page, now we are going to see. First we have studied about the which one? Carbocation, right? Now carbocation contain how many electrons? 6 electrons. Now geometry is trigonal, planar, trigonal planar, and the bond angle is how much? 120 degrees. Bond angle is a 120 degrees. Clear? That is a diamagnetic, right? Diamagnetic, because there is no any unpaired electrons. Diamagnetic, and this is a electron deficient. That's the reason this is a electrophile. This is a electrophile. Clear? Now this is about the carbocation. Next we are going to see about the carbanion. Carbanion. Now carbon contain total 8 electrons. Then geometry will be the pyramidal. Done. Now the bond angle will be the 109 degree 28 minutes. Done. Now it is a diamagnetic because octet completed, and it is having the even number of electrons. Clear? Now this will act as a which one? This will act as a nucleophile. This will act as a nucleophile. Electron sufficient. Now carbon radical. It contain how many electron? 7 electron. Now geometry. If carbon radical with hydrogen and hydrogen, this is trigonal planar. Okay, trigonal planar, and the bond angle will be 120 degree. If suppose carbon, fluorine, if it is attached, now this carbon hybridization will be sp3. Why? Because fluorine contain lone pair of electron. This lone pair and this lone pair will be repel. Due to that, it will be bent. So you have to be very careful. If the carbon and the hydrogen, if it is present, hybridization is sp2, and the carbon and the fluorine, if it is present, hybridization is sp3. Clear? Now this is a diamagnetic or paramagnetic. This is para, because due to the presence of odd electron. And this is a octet incomplete, right? So electrophile. This is a electrophile. Now these are the some reactive intermediates that we have studied. Clear? The next we are going to study about the which one? Now displacement, electron displacement, or types of the electron displacements we are going to see. That is inductive, mesomeric effect, hyperconjugation, and the two which one? Two temporary effects that we are going to see in the next lecture. Okay.